Scene script. Have you ever wondered how we perceive the world around us? How many directions can we possibly move in? These questions might lead you to think about dimensions. Now, you might be asking yourself, what is a dimension? Well, a dimension refers to a measurable extent of some sort in the universe. It's like asking how far you can go in one direction before you have to turn around. But dimensions aren't just about space. They're also about time. Yes, time is a dimension too, think about it. When you plan a meeting, you consider where it will be, that's space. And when it will be, that's time. So, in a sense, we're all moving through dimensions all the time, even if we don't necessarily realize it. So what are dimensions really? In the simplest terms, dimensions are the different facets of what we perceive to be reality, and that's just the tip of the iceberg. There's so much more to learn about this fascinating topic. Think about a point in space. It has no length, no width, no depth. Yet, when we add these elements, we begin to construct dimensions. Let's start with the first dimension. Imagine a simple straight line. This line is one-dimensional because it only has length. It's the distance between 2 points. You can move along this line forward or backward, but there's no other direction to go. This is the essence of the first dimension, length. Now let's add another element, width. Suddenly, we're not just dealing with a line, but a plane. This is the second dimension. Picture a flat sheet of paper or the surface of a calm lake. In this dimension, you can move forward and backward, like in the first dimension, but also left and right. You're not limited to a straight line anymore. You have a whole plane to explore. But our world isn't flat, is it? We live in 3 dimensions. So let's introduce the concept of depth, the third dimension. It's like stacking multiple planes on top of each other. Think about a box or a sphere. In this dimension, you can move forward and backward, left and right, but also up and down. The world becomes richer, more complex, and much closer to the reality we experience every day. To summarize, the first dimension is like a straight line, only has length. The second dimension, a plane, has length and width. And the third dimension, like a cube or a sphere, has length, width, and depth. These are the dimensions we can perceive with our senses, the ones we interact with daily. But keep in mind, dimensions aren't just about space. They can also represent other concepts, like time, but that's a topic for another scene. So far we have explored the dimensions that are most familiar to us, but let's delve deeper. The concept of dimensions doesn't stop at 3, so what lies beyond? When we venture beyond the third dimension, we step into the realm of time, often referred to as the fourth dimension. Just as we move freely in the first 3 dimensions of space, length, width, and height, we also move in the fourth dimension, but in a different manner. Instead of moving back and forth at will, we are constantly moving forward, second by second, into the future. This fourth dimension is not spatial like the first 3, but temporal. However, it is not completely disconnected from them. In fact, time is deeply intertwined with space, forming a 4-dimensional framework known as the space-time continuum. This concept, central to the theory of relativity, suggests that the fabric of the universe is not separate entities of space and time, but rather a single entity of space-time. And here's where things get even more fascinating. This space-time isn't flat, but curved. This curvature of space-time is what we experience as gravity. So when an apple falls from a tree, it's not simply being pulled down by an invisible force, it's actually following the natural curvature of space-time created by Earth's mass. This is the concept of space-time curvature, a mind-boggling idea that challenges our everyday perception of gravity. But why is the fourth dimension so different from the first 3? Why can't we move backward in time as easily as we move backward in space? These questions take us into the realm of theoretical physics, where scientists continue to explore the nature of time and its connection to space. As we delve deeper into these dimensions, we are taken further away from our everyday experiences into a world that seems strange and counterintuitive. But that's just the beauty of dimensions. They push the boundaries of our understanding, challenging us to rethink our perception of the universe around us. It seems we have stepped out of the realm of everyday experience, but that's the beauty of dimensions. What if I told you that some theories suggest there might be more than just 4 dimensions? Imagine, if you will, a reality where time isn't the only dimension we can't physically touch or see. A reality where there are dimensions beyond the 3 we interact with daily. Welcome to the world of theoretical physics, where scientists propose the existence of higher dimensions. These dimensions are not observable in our daily life, but their existence is suggested by certain scientific theories. One such theory is the string theory, which is a theoretical framework where the point-like particles of particle physics are replaced by one-dimensional objects called strings. String theory is one of the most famous theories that suggests the existence of more than 4 dimensions. In fact, it postulates that there could be as many as 10 or even 26 dimensions. But where are these dimensions? Why can't we see them? Well, these dimensions are thought to be compactified or hidden from us because they are folded onto themselves. Think of a tiny rolled-up piece of paper. From a distance it looks like a one-dimensional line, but upon closer inspection you can see that it's actually a two-dimensional object. The extra dimensions proposed by string theory are thought to be similar to this. They're there, but we just can't see them. It's important to note that these are just theories. They remain unproven and are a topic of ongoing research in the scientific community. They offer potential solutions to many unresolved questions in physics, but until we find a way to observe or measure these higher dimensions, they remain in the realm of theoretical physics. But isn't that the beauty of science? The constant quest for knowledge, the endless exploration of the what-ifs. The dimensions we've discussed today, from the tangible to the theoretical, all point to the complexity and wonder of the universe we inhabit. Dimensions, it seems, could be as boundless as our curiosity. Knowing about dimensions might seem abstract, but they have real-world implications. Just think about it. Understanding dimensions isn't just about getting a grasp on theoretical physics or navigating the plot of a science fiction movie. It plays a crucial role in fields as diverse as engineering, computer graphics, and of course physics. In engineering, for instance, dimensions are an integral part of design and construction. Whether we're talking about building bridges or designing aircraft, engineers need to understand the three-dimensional space they're working with. But they also need to consider the fourth dimension, time, especially when dealing with factors such as wear and tear or the impact of weather conditions over time. Computer graphics is another field where understanding dimensions is critical. Ever marveled at the realistic graphics in the latest video games or been wowed by the special effects in a blockbuster movie? That's all thanks to the magic of dimensions. Artists and programmers work with three-dimensional models, manipulate them in a two-dimensional space, and then add the illusion of time, creating the dynamic, realistic images we see on our screens. Now let's venture back into the realm of physics. For physicists, dimensions are fundamental in understanding the very fabric of our universe. They help us wrap our heads around complex and mind-boggling concepts like black holes, wormholes, and even the Big Bang Theory. Ever wondered how a black hole could swallow up light and matter, or how the universe could have expanded from a single point? It's all about dimensions. So, as you can see, the concept of dimensions isn't just a theoretical exercise, it's a tool, a lens through which we can understand and interact with the world around us. And while it might be complex, it's also incredibly fascinating. The concept of dimensions, while complex, is a fascinating journey into understanding our universe. Dimensions are not just scientific jargon, but they are integral to our understanding of the universe. We've journeyed through the first 3 dimensions we're most familiar with: length, width, and height. Ventured into the 4th, where time becomes a perceptible dimension, and even beyond, into the realms of theoretical dimensions, where the fabric of reality becomes less intuitive and more fascinating. Through this exploration, we've seen how dimensions form the bedrock of our perception and interpretation of reality. They shape the very way we navigate and interact with the world around us. They are not just coordinates on a grid, but a profound framework that our universe, and possibly others, adhere to. We've also touched upon the intriguing implications and applications of understanding dimensions, from the realms of physics and cosmology to the everyday technologies we use. Next time you move, think, or simply exist, remember you're navigating through a world of fascinating dimensions.